Good morning to all Cheng. My name is Chu Jason. I will present the introduction part of our group project. First of all, the title of our project is Smart Fish. Refrigerator is the most essential food storage technique in the world compared to other techniques, such as using salt to pickle the food to preserve food. Refrigerator become the necessary electric home appliance. Every home owns a refrigerator to preserve ingredients. In June 2000, one of the biggest electronic company, LG, has introduced the first internet-connected fridge, also known as smart fridge. Because of the advancement of the technology of Internet of Things and artificial intelligence, this technology has used to improve the performance of refrigerator. There are many new functionality of smart fridge that give benefit to the user, such as alert user when the fridge door is not closed properly, remotely control the temperature of the fridge, and create a grocery risk. Next, the problem statement of our project is Smart Fish is not being famous, although many new functionality that will benefit the user, but because of the cost of the Smart Fish is more expensive than the traditional refrigerator, and the functionality is not better than the traditional refrigerator, so cannot attract the people to buy it. User need to check the fridge frequently to know what ingredients have and ensure the quality and quantity. Besides, users also are tormented about what meal should cook and want to know the quality of the food. This problem can be solved by the smart fish, so it can attract people to buy the smart fish. Okay. The objective or solution of our project is using camera sensor to take diagram or video and use the image recognition technique to recognize the ingredient inside the fish. Besides, the sensor also help to monitor the condition of the ingredient. Therefore, user no need to check the fish frequently. Other than that, the data of the diagram will be processed and system will recommend the food based on the data process. And also can help to plan the cost map that can reduce the burden of user. Moreover, the smart fish also can calculate the calorie of the food, which help the user who are on diet or help to maintain the healthy lifestyle to avoid consuming too much of calorie. That's all for my part.
My name is Sikani from Group 14. Today I'm going to present Amazon Web Service IoT Core. Amazon Web Service has provided an IoT platform that allows Internet of Things remotely collect data, secure connectivity, execute sensor management, and allow developers to spread out the application. And the purpose of IoT Core in this project is to retrieve user data such as gender, height, and weight from Internet of Things and store the data into DynamoDB. And we will also use the IoT Core to upload a photo or image that capture from a camera of smart fish and store it into S3 bucket. And next, I will demo how to perform tasks using IoT Core. First, log in into AWS Management Console. Click on the IoT Core. And click Learn. And connect device to AWS IoT Core. And in this part, we're using Windows and Python. And register a thing. As we have registered a thing, so we choose an existing thing. And download the connection kit. The connection kit consists of a certificate and private key that used to connect device to IoT Core. So after that, open the PowerShell. Go to the directory that you save the package, the zip file, and run the code provided by the AWS. Add execution permission to PowerShell. And yes to all. And run the start file to connect device to AWS. So the device has successfully connected to the IoT core. So with the successfully connected to the IoT core, we can publish or subscribe a topic. Go to the test. This part, we can subscribe a topic to the device or publish a topic, subscribe a topic from the device or publish a topic to the devices. So just subscribe all topic. And these are the message that retrieved from the devices. And furthermore, we will use the IoT core to upload an image to S3 bucket. So we will upload a fruit image into this sample fish bucket. This is the image that I have uploaded to the S3 bucket. So let me just delete. So the image has been deleted. So we need a file to upload the image file. In this file, this file has contained the access key and the as the secret key to access the AWS IoT core, that which can get from the AWS IoT core. And this is the bucket name that we will send to, and run the code. Then it will automatically upload the fruit image to the sample fish S3 bucket. And now the fruit image has been uploaded to the S3 bucket. Yeah, the fruit image is here and has been successfully uploaded to the sample fruit S3 bucket. And that's all for our AWS IoT core.
My name is Sanjan Chow. Now I'm going to present the DynamoDB. I created two tables in the DynamoDB, which is user info and meals recommended. In the user info, I set the primary key is the gender, and the age. I set the primary key for the meals recommended is the name and the calories. The item inside these two tables is for the user info. I store the name, the gender, the age, the activity they do every week, and their height, their weight, and the daily calories needed. For the meals recommended, I store the name of the meals and the calorie of the meals and the ingredients. So this information will send to the Lambda. That's all for my part. Thank you.
So now I will explain about the one that we are doing. So that first we will need to have a storage that we created earlier. We use this custom labels console US is to. This S3 has the folder that we wanted that store the picture of the ingredients that we needed later, so that the recognition have the time to do the data sets, so that after that we will get to the use custom labels, then the data sets. We created the fridge, these data sets that contain 3 pictures per labels, so that the later on we create a project, and then we train a model within the project, so that the AI learn about the picture and know what is the picture is, and they will recognize the picture using the label. We can start the model here, or using the API code or the Python code. And also you can analyze the image using the code, or stop the model using the command. And also it has the Python code here. After that, we'll get into the lambda, but first we will get to this lambda function that will getting the user information first, because we will need to calculate the user information so that they can get the calories that the user can consume. And then after getting the user details, it will stop at here and waiting for the analyze peak to start. And then after the analyze peak is done, it will give out the result to the and send to the lambda back, so that the lambda have the function to have the data to do the next function, which is what find out which recipe is fulfilled. Like, we will get the name of the recipe, and then we can if the recipe is fulfilled or is exists, then it will send to the SNS. Also, if left out one or two, most of it is two, then it also will send to the SNS, so that user can know which food they currently can do, and also the food which they left one or two ingredients that they need to either buy it or get it, so that after that it will send to the SNS via this topic to the user that is registered inside, so that the SNS can send to uh, the the user that is currently using this function to do so. And also it get the dishes that is recommended within the calories, and also one or two food that is not yet fulfilled but almost fulfilled, like 1 to 2 left ingredients to complete it. That's all from me. Thank you.